We did an experiment based on the situation problem spill from a pipeline in Cadereyta Jimenez. We poured 200 milliliters of water extracted from the school's lake and poured in a beaker. Before that, we measured the pH from the water to compare it with our results. Then we took 10 milliliters of heavy crude oil and emptied it in the beaker as well, forcing it to mix it with the water. As you can see, petroleum sample is denser than our water. This is what many people can see, but what not many people know is why these two liquids can mix. In terms of solubility, water was our solvent and petroleum the solute. Water forms a hydrogen bonding between its molecules. It means its intermolecular forces are higher. And oil has by it stronger force than dispersion forces. One of the reasons why this mix is not soluble is because the forces between solvent and solute are weaker than the ones, in this case, present in the water. Also because polar molecules dissolve only polar molecules, not non-polar. Also, we look for organisms living in the sample of water. We look through the microscope and we wait until we see the next. As you can see, there is living organisms there. Then we continue with the procedure. The method that we used to separate a substance was filtration. We use a filtering paper in a glass funnel. The way it separates that water is because of the viscosity. Water is not a viscous liquid, so it returns through the paper easily. On the other hand, petroleum is a very viscous liquid, so it has a hard time passing through the paper. The surface tension in the petroleum plugs the pores of the filtering paper and stops the flow of any liquid. Water is a less dense liquid, so it accumulates in the bottom, so it passes through the filter first, then goes to the petroleum and stops. Finally, the results we got were that the pH of water were the same. Initially, we had a pH of 8, and at the end of the experiment, after separating the oil from it, we got 8. On the other hand, the smell changed. At first, we got some kind of organic matter in decomposition smell, and after experiment, we noticed that the water had some chemical smell. In this case, we used a method that was easy to apply in the laboratory because the lack of material we used filtration to separate the oil. Our conclusion is that this method is not practically because, as you can see at the following pictures, at the end we could not remove 100% of all the components of the oil from the water, and still there were some chemicals, so we will need a more accurate method for this task. Components present in this experiment were oil CnH2n plus 2 and water H2O. Here is a photo of our results. As you can see, there are still molecules of oil in the water. That's because our method is not 100% effective. Now imagine this in a huge ocean. First of all, and among a lot of diseases that oil can bring to human health, the most common is respiratory problems because of inhalation. This inhalation in a big concentrations or prolonged periods of time can lead to death. Wildlife is very effective too. It changes the environmental dynamic, drowns species, and intoxicates them, and sometimes these fossil fuels extinct weak species.